I'm Brianna.
We had the Orinoco River, which is in Latin America, in Venezuela and Colombia. It's about 1,300 miles long and covers about 340,000 square miles. And it, like I said, it goes mainly through Venezuela, but it's a little bit of Colombia. And it has four main parts of the river, and it's Alto Orinoco, Orinoco Medio, Bajo Orinoco, and Delta de Orinoco. And each of those are defined by different physical geographies in the regions of the river. Do you want to talk about the sediment load?
I'm going to talk about climate first. The climate of the Orinoco River is tropical, which means there's a distinct dry season and wet season, and also they have about 1,200 to 3,600 centimeters of rainfall per year, and this is mainly because of the intertropical convergence zone, which means like when the trade winds from the two hemispheres collide, it creates humid, warm air, which causes large rainfall, and which sorry, that's all I have to say.
Okay, so then there are these mountains towards the top of the river, and they are called the Sierra Parima, and all the water is flowing north-northwest off of the mountains, and so it's going down. There are a lot of different smaller hills and valleys and things like that throughout the river, so there's a lot of different tributaries that are flowing into the river, which make it this big, huge Orinoco River, and it's really awesome.
And because over 200 rivers and tributaries come into the Orinoco River, there's a large amount of sediment load in the river, which causes the topography of the river itself, and it kind of forms different different shapes and things of that sort. And you're going to talk about the Orinoco resources?
Right. So Orinoco has, like we said, sediment load. There's a lot of different sediments, stones, resources throughout the river, and people are really starting to take advantage of that. If you look at this graph, this is just for gas, natural gas and oil alone. All of these places are set up for different offshore terminals, gas pipelines, oil pipelines, all kinds of different things. So as you can see, there's tons of just like little places, and that's just for the oil and natural gas. So when you add in all of the other stones and precious resources like that, the river is getting a lot of traffic. For a long time, it was kind of unnavigable because of the rainforests and things that are around it. But now that they've realized its importance, people are really starting to get in there and take advantage of it. Talking about that was, your RAS, right?
Right. My RAS was mainly talked about how the oil investment and just different human stresses cause degradation in the river, and that's mainly what it talked about, and just how it was harmful and how they could find ways of prevention. And so they did research with river dolphins actually for that.
And we had talked a lot in class about how humans are affecting natural environments, and I kind of wanted to see how the natural environment was affecting the natural environment itself. And so I looked at the different bacteria that were in the river and different ways that those are being affected, whether it was from the pH or the different chlorophylls and things that are in the river, and how these bacteria are affecting the river based on the different seasons and times of the year. So speaking of different times of the year, you can see our little graph right here of precipitation. So like we said, you do have the other mountain tributaries, but you have precipitation. Clearly you're getting more in the spring. And those abbreviations for the months are in Spanish. In case, Dr. Ron, you're reading them later. That's why the letters might be a little bit different. But yeah, so that's precipitation, and you have the drainage basin. But like, as you can see, all of these graphs are pretty large, which just reflects the fact that the Orinoco River is a huge river. Gracias.